Hello, we're doing checkpoint 4.16. They want us to calculate the partial derivatives with respect to x, y, and z for this function. Secant x squared y minus tangent x cubed y z squared. Okay, let's go through it in order. Let's take the partial of f with respect to x. And the derivative of secant is secant tangent of whatever is inside. So let's have secant of x squared y tangent x squared y, and the chain rule tells us to take the derivative of what's inside with respect to x. So that would be 2xy. That's the first part, and the derivative of tangent is secant squared of whatever's inside. That's secant squared of x cubed y z squared, and now we take the derivative with respect to x. And yz squared is constant, so that's just going to be 3x squared times the constant. Okay, that's our derivative with respect to x. Let's take our derivative with respect to y, and it's essentially going to be the same thing. We have the secant x squared y tangent x squared y, but this time we're taking the derivative of the inside with respect to y, and x squared is constant, so let's just be the constant. And then we have the secant squared of x cubed y z squared times the derivative of the inside with respect to y. Again, y is by itself, and we have x cubed z squared as a constant with respect to y, and then that's it. Finally, let's take the derivative of your function with respect to z, and if we take the derivative of that with respect to z, there is no z in the secant function, so the derivative is going to be 0. We can drop a 0 there, or we can just not write anything. And then now we take the derivative of tangent of something with a z in it. So that would be secant squared of that same angle. That's x cubed y z squared. And now we take the derivative of the inside with respect to z. And so that would just be 2z, and then everything else is constant. So 2x cubed y z to the first power. Okay, so these are your partial derivatives with respect to x. I hope that helps.